are owned by the consumers. But they do not want to consume them. So these are really inputs. So the normal is Z1, Z2, owned by the consumers. Not consumes them. Then you have output prices P1, P2, and the question is what are the input prices? P1 for the output of firm 1 and P2 for the output of firm 2. And then the thing is, or the question is, find the W1, W2, the input factor prices, the equilibrium factor prices. For inputs 1 and 2. And here it's a bit confusing because firm 1 produces using inputs 1 and 2 to produce output 1, firm 2 uses inputs 1 and 2 to produce output 2. If both production functions are homogeneous of degree 1, we get this constant return to scale. So suppose you get CRS, constant returns to scale. Suppose that F1, Z1, Z2, and F2, Z1, Z2 are homogeneous of degree 1. And this implies that if you double all inputs and you multiply this Z1, Z2 by the same factor k, you will also have the output multiplied by the factor k. Fraction. Okay, now the first thing we do is we solve the cost minimization problem. So I show you different things, again pictures with this setup to understand a bit what the trade-offs are at work, how to allocate these things efficiently in an economy between the two firms in the market solution and so on. Solve the firm's cost minimization problem. To obtain W1, W2 for the ratio of input prices which both firms have to pay to acquire the inputs. And then we let CJW be the minimum unit cost. Unit cost. The question is how, so Cj of W, so this is a function. This is the minimum cost, minimum unit cost. This is how much it costs firm J to produce 1 unit of output. This is how much it costs firm J to produce 1 unit of output, at least, because it's a minimum. Okay? This is a function of W, because if W changes, obviously this changes as well. In 2 ways. First of all, if I produce with the same input ratio or input amounts, the W's change, so it can be higher or smaller if the prices change. Second, if the ratio between W and W1 and W changes, so firms will adjust the ways they use the 2 inputs. They might use the ratio of inputs in a different way, which also affects this. So input prices usually go up, let's say, by 10%. One, the other by 8. Probably this will not go up by 9%, but by less. Because the ratio changes from uses inputs in a different combination to get less increase in its cost. So this is the minimum unit cost for 1 unit of J's output. And let HAW equal A1JW, A2JW. Is an input combination now. Input combination that achieves.
I'm sorry, is this let AJW equals
A1JW or A2JW? These are input combinations that achieves this CJW, so we use it. Now I draw some pictures. So the first thing is between Z1J and Z2J. What is Z1J and Z2J? This is how the firm J uses inputs 1 and 2. Okay. So this is now the optimal choice between the two inputs Z1 and Z2 in firm J's production process. And how does this work? Well, here we have this. This is a production gradient. Sorry, the production isopoint. And this is minus W1 over W2, so input cost ratio. And this is how you optimally cell produce. Okay? And here with M1, A1, A1J, and A2J, depends on W. And this is production isopoint, unit isopoint actually, unit isopoint. So to produce 1 unit of output, for example, could be the unit isopoint, then you get the combinations of Z1J, Z2J, with R plus squared, such that the output of the firm is exactly 1. So if the ratio W1, W changes, you will get to a different point on this optimal input combination. Okay? And well, if both change, then your costs go up. The next picture is now in the space of W1, W2 in the space of these input factor price combinations. Now what I do is I let CW equal C. The cost to produce some amount of output is fixed. And then I can see if these W1 over W2 changes. What I do is you get a different transparency conditions than here. And then for each of these conditions, well, this is W1, W2. If I change to W1 prime, W2 prime, and then I get here the gradient, which is how much I use in production. Different production, W prime. Different combinations of input when the input prices change. Okay? So you would get the unit cost function. The unit cost function. I will explain it again in those pictures because they are related. And you see. You see these two things at work which I told you. Well, if the prices change, then obviously you have a higher cost. But for different inputs, for different input prices, input price combinations, you will just adjust your production in order to keep your unit cost constant. If one unit cost for one of the inputs increases, the other decreases, then you can do this. If both increase, you will have a higher unit cost. You have a shift. But if you have one increasing, one decreasing, you can adjust the production in a way of using more of the cheaper input and less of the more expensive one. This is called Douglas isoquant. If you have substitutes, you can also do it. With complements, you cannot. Because with complements, you need the more expensive input you also need, so you cannot substitute away to the cheaper. You need Douglas most of the time, substitutes works up to. And here you have this space of how much input to use on each of these two inputs, and here you get, well, at this ratio minus W1, W2, you get this production isoquant, you get 1 unit of output, which is just a tangent to this budget line, and this is the optimal input combination. And if it shifts, if it turns, then you get to a certain point on this production isoquant.
If the consumers don't want to consume
Consumers.
Yeah,
Okay.
don't want to consume the endowments, then why?
It's like inputs you sell to the firm. It's capital and labor. So you want to sell, you have some money on your bank account, you invest it in firms, plus you have some, you give it to produce to the firms, no? And you have some labor, you again work in the firm. You have some amount of maybe input of these production factors, which is your time you want to consume as leisure, but some you dedicate to working. And you have some money you don't want to consume, but you invest it in the firm, to work. This is money. So this is how you use this. This is the easiest way to think about it.
Can you show this graph again?
This one.
Yes.
So the key thing is to see these W1s and W2. So we have here the space of factor input prices, how much it costs me to buy 1 unit of input 1 and 1 unit of input 2. And this is like this unit cost function is equal to C. So what happens if the prices change, but I want to have one price increasing, the other decreasing? If I get this, and I just, price ratio changes, I change the way I combine the inputs. Instead of using one type of input combination, I use a different one. If both increase, then you have to shift it up, then you have a higher unit cost. So the unit cost is not anymore constant, but you move up. Same thing here. So here this is equal to output is 1. If both shift up, both costs, what you will do is you produce less than 1 unit of output. Or to produce the same output, you need to pay more. Okay, so this would be, and this is more intuitive, because with this it's very difficult to make exercises or to do stuff. We will not do much exercise, but I will show you a couple of things. Like you get an intuition for macroeconomics more in this type of how it is related to your analytical macros, microeconomics. Then I draw you an edge first box. How could you think about allocation of inputs in this economy? Edge first box was the allocation of inputs between the two firms. Characterize non-wasteful allocation of factor inputs. Non-wasteful allocation or allocations of factor inputs among the two firms. Factor inputs among so here we get the size of this edge house box is the total amount of endowment of the two factors in this economy. And then we do basically what you start with. Now we assume that the firms own the initial endowments. This is how they are owned. So this is the amount owned by firm 1 of factor 1 initially. Set 2, 1. This has to be set 2. Set 1, 2. Origin of firm 2. Origin of firm 1. So this is 2, 1. 1, 2, 2, and 1, 2. If they start there, then you can draw production isoquants. And if this is a production isoquant of firm 1, this is a production isoquant of firm 2. So these are production isoquants. then you see that in this lens, both firms would make an improvement, would produce more efficiently, and this means a larger profit. This constant returns to scale, if we assume CRS implies that the Pareto set is a diagonal. The diagonal is basically the line where all efficient production takes place. Pareto set is the diagonal. This is where all efficient production takes place. So if you're outside one of these points on the diagonal, you can improve by reallocating your inputs. You can improve the outputs of both points. Or at least one, but you can improve both points. If you don't have constant returns to scale, for example, something which is entirely below, something like this. Okay, so it's entirely below the diagonal or above the diagonal. This Pareto set. So here's a Pareto set. What you get is which one first uses inputs more efficiently. So for each point, and this you can check on the Pareto line. Here, for example, for one uses more of input 1 than of input 2, and from 2 the other way around, more of input 2 than of input 1. So from 1 uses input 1 more efficiently than from 2. From 1 uses input 1 more efficiently than from 2. And then you can think about if the two sectors are sector 1, which uses more of input 1, think about service sector, which uses more labor. So service sector uses more labor. The production sector uses more capital. This would be input 2. Good. Given this, I give you the definition, how we can say that the production of good 1 is relatively more intensive in factor 1, which is this what I've here, the picture here. This is formally, we can say that the production of good 1 is relatively more intensive in factor 1 than is the production of group 2 if we have A11 of W over A21 of W is strictly larger than A1W over A2W for all factor prices in W. Okay, what happens here is when one uses more of this input 1 than input 2 does. And this is formally, we can say that the definition of this, the production of group 1 is relatively more intensive in factor 1 than is the production of group 2, which is this combination. And a couple of more pictures and explanations. So how does this look like? Well, actually, I draw the picture. So in the address box, like this one, this idea, how would it look like? So you have that you have this optimal tangent condition, which corresponds to below the diagonal. This would be set star. And here you get, if you draw a line from the origin of each consumer, the slope for each firm. The slope for firm 1 would be this the amount A11's W star. At any point you get the same ratio. A11 W star, A1 W star. And from firm's 2 point of view, you get A2 W star. This is A1, 2 W star. W star. So you get Z1 star star. Input price ratio is equal to this optimal factor input ratio. A1 W star. 2 1 W star. And here you see this is larger for from 1. So this is A11, A21. You have A22, A12. This is strictly larger than Z1, Z1, 2 star. W star, A2. Good. There's a picture corresponding with this definition. Okay, so within this framework, and this is something which comes from international trade or macro up to a point, but it's probably more international trade, which is using how you can use these frameworks. And again, in micro, we usually don't use this type of models because it's not very, so for production we have very little. Usually we do this consumption, this exchange, which is more typically micro. And this is like the step from micro to macro. But there are two theorems, Dr. Samuelson and Rybczynski, which are based on this type of reasoning with the two firms, the two sectors. And one of them is what happens if equilibrium prices of factors change. What happens if these inputs change? So the equilibrium price of the factor more intensively used in the production of good chain increases, then the price of the other factor has to go down. Okay? So this is Dr. Samuelson. If the equilibrium price of the factor more intensively used P chain increases. P chain. So the price of good chain increases. The price of good P of good chain increases. So what I'm going to say, if P chain increases, then then the equilibrium price of the factor more intensively used in the production of good chain increases. And the price of the other factor decreases. And the price of the other factor and then you can think about, so when we started with this inflation like 2025, so 3 years ago, we started with inflation going up. First, all the consumption goods went up in price, and this was basically the other way around, but in the sense that Well, because we had price increases in inputs partially, or price increases in outputs, but as a consequence also the input prices increased. So at the beginning consumption goods, and what went down in relative terms were the labor cost. So first our wages were depressed, so our relative wages were lower, because the prices of the output goods, of the consumption goods and so on increased. And so first the labor share of the economy went down. Now in the last 1 or 2 years, all the services go up. Service prices go up, which means labor costs go up, and the wages rise relatively more than the other input factors. Okay? So this is more or less what is said by this Stolper-Samuelson theorem, and this is based on this basic reasoning in the address box. There's 2 sectors, 2 types of input. This is basically what Stolper-Samuelson said based on this type of model. And the other model, so there are 2 more which I'll show you. One is Rybczynski. Okay. This is how the guy is called, Rybczynski theorem. What does this say? Well, now we have that the address box, the size of the address box changes. For example, due to the new resource discovery, the endowment of one factor increases. Or think about what, for whatever reason, you open up your borders and you have more immigrants coming, so you have more labor. For whatever reason, you have a large amount of input of one factor. So if, for example, due to the resource discovery, due to a new resource discovery, this is the initial one, but if the endowment of a factor increases, what happens? Well, the production of the goods that uses this factor more intensively will increase, and the production of the other good will decrease. Okay? If the endowment of a factor increases, then the production of the good that uses this factor more intensively, relatively more intensively, increases. And the production of the other good decreases. So one of the inputs is more abundant, then the production which uses more of this input in relative terms will be increasing, and the other one will be decreasing. The production of the other good decreases. And what happens here in the address box? What we do is basically, when you make this address box larger in one direction, the production of the good benefits, which is, well, if you are here below the diagonal, this is from 1. If you increase it in the other direction, this is from 2.